Hello, discrete math fans. Earlier in the class, we made mention of something called the axiom of extension, and it says that two sets are equal if and only if they have exactly the same elements. Membership is the only thing that matters. Now we're going to restate this using our language of subsets, and we'll make a definition to say that given sets A and B, we're going to say that A equals B if and only if every element of A is in B and every element of B is in A. And you can write this symbolically by just saying that A is equal to B if and only if A is a subset of B and B is a subset of A. So as an example, let's create these two sets and say that A is the set of all integers such that n is equal to 10q plus 27 for some q in the integers. And let's let B equal the set of all m in the integers such that m mod 10 is equal to 7. And we're going to prove that A is equal to B. So in our proof, we have to say, remember, that in order to show that A is equal to B, we have to show two things. A is a subset of B, B is a subset of A. All right, so in order to show that A is a subset of B, we always start by choosing an arbitrary element of A. Then we can say that there is an integer q such that n is equal to 10q plus 27. That was the definition of what it meant to be in the set A. All right, now we can rewrite things. N is equal to 10q plus 20 plus 7, and then we can move off the 10 by factoring it. And now, once we have that n is equal to 10 times some integer plus 7, that tells us that n mod 10 is equal to 7. And therefore, we can conclude that n is an element of B, and so we've proved now that A is a subset of B. Let's go the other way. Now let's choose an element m in the set B. That means that m mod 10 is equal to 7, or another way of writing that is we can say that there is an integer p such that m is equal to 10p plus 7. And in a similar way to what we did before, we can rewrite things so that m looks like 10 times some integer plus 27, and then we can conclude that m is an element of A. And that means we have proved now that B is a subset of A. And our final statement then, since we have proved the subset relationship in both directions, we can conclude that A is equal to B. Okay, that's all for now.